So in this paper, we visit the classical question in economics in thinking about policy instruments that regulate externalities. So in the textbook, talk about two types of policies, Pigouvian tax and cap and trade that regulate externalities. So we can think about them as price instrument versus a quantity instrument. In reality, however, there are very few cases of exact cap and trade policies, especially in developing countries, perhaps due to the weak institutional capacity or the difficulty in actually building exchanges or monitoring production. Instead, we see more often the command and control supply reduction policies, with examples such as factory shutdowns, moratorium on fishing, logging. So the more kind of relevant practical comparison would be between tax and a supply reduction policy. This comparison between these two policies can be ambiguous when there is uncertainty. So we're going to think about a case where the policymaker has to choose a policy before the uncertainty materializes. It could be, uncertainty about the demand, the supply, or the externality. So the key intuition of this paper is kind of relate to the classical Weizmann 1974 trade-off based on the relative slopes of marginal benefit and marginal cost. So kind of the key intuition here is think about the shape of the externality. If the marginal damage is increasing, so if the externality is very convex in quantity, then you're going to have a very big loss when the quantity deviates from a certain target. In that case, you would prefer to use quota. When the external damage is linear, or you're going to have a constant marginal damage, so you're going to prefer tax. The Pigouvian tax can actually exactly correct the externality. That's kind of the key intuition. With quota, the comparison is simpler, but with the supply reduction, it's similar to quota, but it's more complicated, as we're going to think about supply reduction as a rotation of the supply curve. So the efficiency ranking between supply reduction policy and tax policy is going to be a question. We study this policy comparison in the setting of China's coal industry. China is the largest producer of coal and actually also largest consumer of coal. Also, coal industry itself is an important sector to China's energy security as well as the green transition. So starting from 2016, the government started a series of so-called supply-side policies. The supply-side reforms that reduce the capacity of the coal, reduce the supply of the coal. So there are policies such as the shutdown of small mines and the suspending new coal, new mine approval, and also put a lot of constraints on the production, which lead to a surge in price in 2016. In this project, we're going to take the capacity as given, but we're going to focus on the effects of the production constraints modeled as the rotation of the supply curve. So what we specifically do in this paper is first, we're going to estimate an empirical equilibrium model of coal demand and supply, where we're going to estimate the policy of the production constraints as rotation of supply curves. And then we're going to quantify the effects of the supply reduction policy, including both its economic surplus, its impact on the economic surplus and the environmental impact. And the key novel contribution of this paper is to develop a criterion so that we can rank the policy, this supply reduction policy with tax policy. We impose very mild assumptions on the external loss function, which captures the externality. What we find in a nutshell is we find the observed supply reduction policy reduces the economic surplus, which is not surprising, but it also reduces the environmental cost, although it's not really the target of the policy. And the total welfare effect kind of is zero, canceled out by these two opposing factors. What we also find is that there exists an alternative tax instrument that would be welfare improving compared to the observed supply reduction policy. This paper contributes to three strands of the literature. The first one is the empirical assessment of the Weizmann type of trade-off. The prior work typically do this based on integrated assessment models or calibrated theory models. We're going to do it in the estimated equilibrium, empirical equilibrium model. This also speaks to a recently surging literature on industrial policies, as well as the economic effects of environmental policies. And the main contribution is we provide a novel ranking criterion based on very minimum assumptions on the objective function of the government. And actually, we impose no assumption on the observed policy being optimal. And lastly, this also contributes to studies on China's coal industry. We provide new estimates of the demand and supply elasticities, which are inputs of the evaluation of the policies. Okay, let me jump into a toy model that illustrates the main idea. So let's think about a market with the supply function. For simplicity, let's just think about a linear supply function and a linear demand function, as well as externality captured by this external marginal loss. All these parameters, these A's, A0, A1, B0, B1, R0, R1, all these parameters are known to the policymaker. But the uncertainty comes from, for example, here, the demand shock, epsilon. It's not realized before the policy is made. So the policymaker has to pick a policy before the epsilon realizes. I'm going to define the objective function of the government as the sum of the economic surplus, which is the integral area between demand curve and supply curve, which captures the economic surplus, minus the external marginal loss. So you take the integral from 0 to equilibrium quantity to star. If the government picks a tax policy, the equilibrium Q star would be captured by, you're going to have minus tau on the numerator, which effectively is a shift of the supply curve. We're going to model the supply reduction policy as a rotation of the supply curve. So the government is going to pick an alpha 1, an alternative alpha 1 that is different from the actual supply curve. So we're going to think about this as increasing, rotating the supply curve inwards, which leads to different equilibrium quantity, where you simply replace A1 with alpha 1. So these are the two policies the government thinking about when with the objective to maximize the welfare. Now, we can simulate this model kind of very simple. We put some numbers as an illustration. The key idea is when the slope of the marginal damage is 0, so when the externality is linear in quantity, so the marginal external loss is constant. In this case, from the economics textbook, we know that the Pigouvian tax is gonna exactly correct for the externality. So the optimal tax is gonna be the best policy that dominates the supply reduction policy. However, when the the slope of the marginal damage becomes larger and larger, the optimal tax may not be the best policy. Actually, no, you're gonna have the supply reduction policy that gives a higher expected welfare than the tax policy. What's the key intuition here? So the idea is when the slope of the marginal damage is zero, when it's a constant, now the tax can exactly can correct for the externality. But when the marginal damage becomes larger and larger, so the overall externality is very convex. In this case, you would like to kind of rotate the supply curve in order to correct for the externality. And there is kind of a threshold above which the supply reduction policy starts to dominate the tax policy. That's kind of the simple economics. Now, this it's going to be in the economic surplus as well. So this comparison is kind of simple if we know the slope of the marginal damage. Now, the key challenge is, although these parameters are known to the policymaker, it's not known to the researchers. So the empirical IO has developed a lot of tools to estimate supply, demand, but it's very challenging to estimate the external marginal loss. So we're gonna make barely any assumptions on the marginal loss and think about what's gonna be the better policy choice. So this is a challenge. We don't know. We as researchers do not know the loss function. So how do we compare these two policies? We do not know them because may be very hard to estimate the externality in reality. For example, in the case of the coal industry, the externality includes the environmental impact on the air pollution, on the carbon emission, as well as associated production costs, such as leading to death. All of these considerations make it hard to really estimate the loss function. So the key idea of this paper is let's write down this objective function, the welfare, into two parts. The first part is the economic surplus, where we have tools to estimate these objects reasonably well. And the second part is the externality, the external loss function, which we do not really know how to estimate them well. Now, given an observed supply reduction policy, think about this as the coal production constraints that happened in 2016. Given this type of policy, we're going to consider a tax that exactly matches the economic surplus part. We compute, we find a tax that gives exactly the same amount of the economic surplus, and then we're going to ask whether this tax has a smaller external loss or not. If we can answer this question, then if the answer is yes, then we find a tax that dominates the observed supply reduction policy. So this gives a sufficient condition of a better tax instrument than the observed supply reduction policy. Then the question is, how do we answer the second part, whether this surplus matching tax does have a smaller external loss or not? So the key result builds on this theorem that when the loss function is finite on a finite support, when it is increasing and differentiable, that's the only assumption we impose on the loss function. As long as the random variable Q1 first order stochastically dominates Q2, then we can for sure say that the expectation of the loss function over Q1 is larger than the expected loss over Q2. This serves as the mathematical foundation of the key evaluation criterion. Then the procedure is as follows. So for a given supply reduction policy, we compute the economic surplus based on the estimated demand, estimated supply, and the associated equilibrium. And then we're going to look for a tax that exactly matches the economic surplus of the supply reduction policy. And then we verify, we're going to look at the quantity distribution under these two different policies. We simulate the model with various realizations of the shocks, and then we compare the distribution of the quantity under these two alternative policy schemes and verify whether Q1 under the tax indeed stochastically dominate. Sorry, Q1 under the observed policy indeed stochastically dominates Q2 under the alternative policy. Now, if that's indeed the case, then we find a tax that dominates the observed supply reduction policy. So we're going to call this tau star, in this case, the SMD tax, short for surplus matching tax with dominated quantity distribution. Of course, this is only a sufficient condition. If you do not find such a tax, you cannot say that there is not a tax that dominates the observed supply reduction policy. But we do find that for many demand and supply functions, you indeed can find such surplus matching with dominated quantity distribution tax. Okay, let me now put some numbers to this idea with the case study on the China's coal industry. So the majority of the coal are these two types with anthracite. This is kind of higher quality with higher purity coal. The other one is the bituminous coal, which is lower quality. The majority usage of coal in China is for electricity and coking and cement. And actually, the power plants in China adapt to mixed grades of coal, so they can use both of them. We're going to think about the China's coal market as a national market. It's the different provinces are connected by rails, rivers, and in the data, actually, we find the share of a province's coal shipped to another province is very stable. So a possible reason is they're gonna them contracts with the promised delivery quantity. So those features are kind of considered, take into account in the. So the key policy we study is the 13th 5-year plan initiated in 2016 with a lot of focus on the so-called supply side reforms, which limit production with the goal of improving the profitability of the coal industry, improving the safety, probably with also other concerns on environmental impacts. The main data sources we use include the cross provinces shipment data, the capacity data, and the monthly consumption for each province and production for each province. So some of these are kind of commercial data, but basically you're going to think about, we have a data set of P, the price, and the Q, the quantity for each province, as well as the transportation, the shipment between any two province pair. Brief summary statistics. So on average, each province consumes about 1 million tons of coal and produces on average 1 million tons of coal per month, with very little share of the imports. So we're going to introduce kind of foreign country as a separate province, but it accounts for a very small share. So here's the descriptive, the evolution of the price and quantity for the coal. You see clearly after the supply side reform, the price of coal surges, it increases by, depending on which type of coal you look at, it increases by about 40 to 50%. And you also see kind of a reduction in production, although it's less dramatic. We're going to incorporate a few key data patterns when we estimate the demand and supply. One key data pattern is that if we do some kind of within-between decomposition, we find that some major provinces drive the quantity reduction, including in Mongolia and the Shanxi province. And also large SOEs mostly drive the quantity reduction. Also, as I mentioned, the province's share of coal shipped to another province is very stable in the data. So we're going to take that as exogenous. We do not model it. The possible reason is they may have long-term contracts with the shipping amount. We're going to have a model of provinces, so we do not model coal mines. And the supply reduction policy is modeled as the supply curve of each province being rotated. Basically, the policy shifts up the marginal cost. That's how we think about rotating the marginal cost. So first, the demand estimation. So that's the key equation. We think about the demanded quantity as alpha times log price. Alpha captures the demand elasticity. We also include the amount of wind power generation in that province. We're going to include a bunch of fixed effect, the province fixed effect and the month fixed effect. We adopt two sets of shift share instruments for the demand estimation to account for the differences in policy timing and exposures. So one of them is the SOE shift share. We interact the policy start indicator with the share of SOE production. The second one is the capacity shift share, where we interact the share of small coals in each province, because the policy actually shut down a lot of the small coals, interacted with the policy indicator. I'm gonna save all the details. So what we find here is that the demand elasticity is about minus 0.5. Next for the supply. So we're gonna think about the effective marginal cost faced by each province. They're gonna equate the marginal cost with the average price, which is the average price of a weighted average based on the shipment share you get from each province, weighted by each province specific prices. We allow the capacity to affect the marginal cost. The most important thing is we're gonna estimate the policy effect that rotates the marginal cost curve. Here we use instruments of both the weighted average of the wind production as well as the demand residual as the instrument. We estimate this, we find that the elasticity on average is about 1.1 across provinces. So this figure shows how basically the estimated impacts of the supply reduction policy. We find indeed for most of the provinces, their marginal cost is increased after the policy. Although with a few provinces with an estimated elasticity being smaller than 1, but those provinces produce very little coal. we're going to take that into account, and this is Qinghai. Yeah, somehow it has a huge standard error here. Also, I think it's not a big coal-producing province, so it's not going to affect the result much. So this is the policy we have in mind, our reduction policy, modeled as kind of this shift of the rotating of the marginal cost. What we do is we're gonna compare this observed policy first with the counterfactual of no policy. This gives us an estimate of the impact of the observed policy. And then we also gonna think about alternative policy that you impose a uniform tax across provinces. So that kind of kills the misallocation effect. And lastly, we're gonna think about whether, going back to our key novel criterion, whether there is a tax that is better than the current supply reduction policy. So we simulate the model and we compare the counterfactual economy where there is no such supply reduction policy. We find that the observed policy increases the price by about 160 yuan per ton. It reduces the production, reduces the consumption, so it reduces the economic surplus. At the same time, we also kind of provide a proxy or impute the environmental cost. We're gonna take some estimates from the literature of cost of area pollution, of the producing coals, and also the carbon emission. So that serves as an imputation of the externality, the environmental cost. You may a lot of questions on the details of doing that. That's why we want to produce a criterion that does not really rely on how you impute the environmental cost. But under this, we do the best we can do. Under this available estimates of all the externalities, we find that the total effect basically cancel out with the reduction in economic surplus as well as a reduction in the environmental cost. So the sum is basically zero. We compared to a uniform tax across provinces that generate the same equilibrium quantity. So by construction, the production is the same under these two policies, but it reduces consumption. So that captures the welfare of misallocation in the observed policy as this uniform tax policy kind of has a higher overall welfare. So this is the exercise we really want to speak to, which is when we do not really impose any assumption on the externality, we do not use the estimates borrowed from the literature. Is there a tax that is better than the current policy? So what we do here is for the observed supply reduction policy, we compute the tax that generates the exact amount of economic surplus. And then we simulate the model thousands of times and plot the distribution of the equilibrium quantity. Now the dashed line is the distribution of the quantity for under the observed policy. The solid line is for the surplus equivalent tax. It's clear that we do find Q1 stochastically dominates Q2, which indicates that we find tax with exactly the same economic surplus, but with the stochastically dominated quantity distribution. Based on the theorem, we can argue that this tax provides a higher overall welfare than the observed policy. So we indeed find a tax that can improve the economic welfare. Let me conclude. So the key contribution of this paper is to provide a novel ranking criteria based on the surplus matching tax with dominated quantity distribution to compare the welfare effect of supply reduction policy with the tax policy. We implemented it in the China's coal market with an estimated empirical equilibrium model. And we find that the observed supply reduction policy indeed reduces the economic surplus, although it increases the producer surplus by increasing the price a lot. But taking into account of the external damage, the overall welfare is roughly zero based on the imputed effect of the externality. But we do find that there also exists an SMD tax that can do better than the observed supply reduction policy. That's all for what I have.
Hello, everyone. Thank you very much for joining this session. I really appreciate it. I'm Zhang Huan Li, a third-year PhD student from the Hong Kong University of Science and Technology, the Guangzhou campus. This is part of my dissertation research, and I work with my wider team. There are all about security and all the other related environmental issues. I begin with introduce of the policy and climate tension. I know that the Chinese government has the food security and the top one. I also heard of this policy mandate that the rice bowl must be formally held in our own hands, set by our president. And to achieve this goal, the Chinese government, they established a series of action policies. I'd say they are kind of rigid. As you can see in their slogan, the boundaries clearly drawn on this board. That means that not only the area, but also the exact location of the power plant is already decided by the regulation. However, the overall policy are shifting climate conditions of the power migration so there is a conflict. Let me elaborate it more clearly. The problem of the moving parties on a big land. The policy mandates requires to preserve the designated cropland area and keep the green acreage stable in specific location. However, there's another point. The climate pushes for the spatial realm. There are biophysical needs to optimize the land use and crop structures. So here is our question. How do the farmers make decisions in a constrained environment shaped by the competing market, climate, and policy pressures? And going forward, how costly they study of that protection policy? I'd like to talk about the gap between the potential and reality of farmer climate adaptation. There is a branch of literature they talk from the theoretical setting of fasting. In detail, they measured the comprehensive optimization of the crop in order to maximize the welfare or minimize environmental risk, but their modeling still under published on the natural communication or other internet literature. And there is also another branch of they are coming from the empirical flow perspective. They provide a lot of reduced form evidence to use the causal relationship to identify all the values of and newly published on the theme of the DSE of environmental and agricultural. So you can say from the both sides, they all treat the transition time and dynamic as a platform. That's also there. We want to quantify dynamic bring the adaptation. There's a of the land use model. So we have some paper somewhat with the area adjustment. That's climate, how the agriculture and the non-agricultural land. And another paper models the decision of farmers within the land, just between the small and big. So although our model, honestly, it has no contribution to the methodology frontier, just the previous framework, but we think it may be relatively to find a gap this big. The dynamic net structure, only model of structure of area. There's about a little details about the policy. Their one resource is there are policies like the national red line. And actually, the average targets is assigned to the local officers as part of their evaluation, performance evaluation. That means the land use is somehow related to the administrative mandate and making the conversion costly. Another point, there are some policies protect the minimum purchase price and the rise of crop specific subsidies. It will raise returns for some debt-related crop. So it will discourage the population procedure even when the climate conditions change. From the policy, how the farmers from climate. I think there is some along the market. First, central market. Farmers, they will use land comparable land or abundant when the other is the intensive market. Farmers, they will adjust their crop structure and rotate their crops in the existing land. And the way farmers dynamic and dynamic means they are previous and influence the current condition. The rotation is doing some rotation effect and will influence the probability effect. Much more different from the condition of land. Former to the just the management adjustment, but later that also about how we define our choice set. Can see the crop transition that is computed from our observed data. On the horizontal line is the current year's land use. On the vertical line is the previous land use. And we can see there are and we define our study region as the agricultural frontier. That is the ever area. The underlying assumption is that only the farmers within this frontier, they face the agricultural and the outside they are problem and outside yes, and the land. What about other forms of it includes better inclusion of our research structure. This is the visual sample set. In the right part, in the yellow part. The yellow one. There are other crops we consider. This consists of and the red one is extensive crop. It means there are non-crop and we can see the mix driven by both climate level is the temperature warmer and will unlock the previous and the policies. There are some policies like for example, policy will incentivize the farmers to plant corn but not other crops. About the model, since our language data is fed data and so we just equal the small farmers at each pixel, and we think they made unique decisions and they won't affect the whole market. And each period they made decisions to maximize the effect. W of the function of climate state, while the K is the just the previous land report and generate dynamic. Our choice set is very natural. Every layer. First is farmers decide to crop or not crop. Second is if they decide to crop, which type of crop. Or else if the cannot go detail because it's really very simple and I think most of you have even fancier model than mine. Yeah, we just bring into the matrix structure. Yeah, and make the state condition on the previous land. Yeah. No, this price data, they are administrative data at the whole. Thank you very much. This is our the conflict committee is our four parts. The constant alpha bar is the top specific function, capturing the average of the quality constraint. And the conversion cost depends on their specific length and which means the arrow curve graphic down stop and they follow this description, allowing the and this is our final linear estimation equation. By just following previous words and combining the immersion and affinity dependence, we will drive this equation. On the left-hand side, it's the dynamic relative probability, and the tau term is the intercept. It captures the friction and heterogeneity. It includes both the transition-specific switching cost and the crop-specific policy bias probability of the lab. Somehow like the feedback. And the delta are termed profit incentives. Each coefficient represents the marginal rate of income. And the sigma term is the negative relation measures to the comparison. This definition is also very basic. It gets to the first difference estimation, the difference of some time invariant unobserved variable, and estimate the alpha hat and sigma hat. Second, we recover structural parameters by calculating the residue between factors and average them over time. Finally, we decompose the cost and the bulkhead effect. We consider two parts of the narrative. First is the within one. That's called the within the next structure or equivalent current of the crop. So we sum the potential revenue of each competing crops in the same year. Made at the secondly is about the dynamic. This is very intentional, and we also follow other integration with the Quasi-Experiments instrument. Here are our baseline results. First, for the first stage estimation, we get a very high net correlation around 0.82. It means that the crop within the agriculture net, they are closely substituted, but they are very distinct from the non-crop crops. And the price response is around 0.75. The unit is 10,000 CNY per hectare, and the intuitive meaning is that revenue advantage of 10,000 for a crop, say relative current crop, will increase the dynamic of oats, of next year by about 0.5. And second, we recovered parameters from the second stage estimation. We think the sign is negative because it reflects the situation land use may cause the utility loss. And we also clear about their mechanism. The exit cost is far more larger than the entry and the location cost. We think that reflects the strong policy force to make the problem don't move. They actually abandoning some farmland. And you may think those coefficients are still not very economic significant, so we made some advantages. That is defined as the percentage change caused by the percentage price change. And to equal our to make the elasticity both the top one and the one. Both the top one is the and we also check the depth. So we design both the unconditional and it accounts for the total change in the absolute area and also the offline. Crop share on price change. Find that a 1% increase in rice revenue will lead to a 0.65% increase in rice area, while 0.58. We think it coincides with the agriculture. Those there is that means if time to plant one bad crop, it will make the yield get some loss because the nutrition will loss. Yeah. So if you rotate the crop choice, you will get better long-term yield. Second, we decompose the adaptation margins in the two ways. First, from the intensive margin perspective, we analyze the within-net and we actually measure the cost elasticity. That is, for example, 1% rise in corn price will reduce the floating area by about things. And the decline actually, if we look in more detail, in the soybean share, the cropland is larger than the area. This reflects the fact that the situation in adaptation is mainly driven by the impact of aging and not the land abandonment. The land abandonment is by the patterns from the extensive margin perspective, we can observe our high barrier. The insight is that if only for a certain land, if only one crop's price right, it won't affect something. Won't make the farmers decide to transfer from non-crop to crop. But however, this land becomes very valuable and it's very productive, meaning every crop planted in this land will get a profit increase. Then the farmers will decide to transfer from non-crop to crop. And here just all different regions respond of the on-crop selected. You can see there are very and basically they are more sensitive, while the others are not. And they also have different response. Last is our policy on the practical design. We want to model the future climate damage, how they will influence the crop yield, and then influence the government subsidy. First is how we define damage from climate. Just use some literature of the damage function of climate. Just calculate the counterfactual yield under the warming scenarios. You can see it here, clicking the high temperature. And actually for the data, which is the climate sensitive parameters, it can be different from crop to crop. And there are many different about that. But in our baseline, that's a very simple universal data to measure all this crop climate change. The value is actually each additional day within the temperature being larger than 35 degrees will reduce the overall agriculture gas by around 0.5. It can calculate under a moderate warming scenario. The value is the mean space and adaptation pattern. Yield load average each crop will drop by 0.1%. And if we want to aggregate them together and get a comprehensive understanding of how it influences the food security of China, we will calculate them, transfer them all to the calories. And we find the total calorie production will decrease by 50,000 kilocalories per hectare. And then we measure if the government want to offset this yield loss and make the farmers still want to do some cropping rather than transfer to other lands. How much subsidy should we give to the farmers? And we calculate amount roughly 700 CNY per hectare to keep the farmers still in agriculture despite their low returns. And at last, in the future, we want hypothesis about the reducing friction scenarios. Because there are literatures about how we can actually lower the switching cost and make the overall agriculture more suitable to the future climate. However, we are still figure out how to map this digital channel into our realistic estimated transition cost. Thank you very much. And these are the case stories. Sorry. These are the takeaways for my research. Firstly, our research is built with the tension scenario. That is China's security region built on the area-based problem, where the climate change in where the crops can be so productively grown. And for the method, we use an estimated dynamic ratio model to capture physical and adaptation electricities on both extensive and time. The key findings, we find there are large easy costs make the top-line management very difficult. Therefore, most of the climate and required signals they respond to the within top-line switch process. And the on-price elasticity they are moderate and coincide with other agricultural findings, but we also find they are very exciting. Finally, for the policy implication, we find that under a multiple taking the current top-line target reverse and around 700 sigma input something. Thank you very much for listening. Actually, I think thank you very much for the question. The policy has because there are in recent days many people they want to build some buildings on the agricultural land better than make that level and the option.
Thank you for having me here. So I'm Yuchen, and today I will present my working paper, The Quality Provision Through Regulation and Reputation. So let me start from the motivation. So low quality provision is a very critical issue in many emerging markets. You can see that in these markets, there are full of the counterfeits or low quality services. And to encounter this problem, so from the economics perspective, the low quality provision problem is majorly induced by information asymmetry. So the quality is very difficult to verify for the ordinary consumers. And to encounter this problem, the policymakers worldwide may use entry barriers. So they establish a licensing system to set the minimum requirement on the upfront investment, and to do so they can screen out the low quality providers and regulate the market. And this practice is highly aligned with the public interest view or the Pickering view that if you find that in the market the quality is very uncertain to the consumers, you need to increase the entry barrier. So though even if it may increase the market power and do some that will lose, you still need to do so, and the net effect can be positive. So, but one thing in this classical view is neglected, that is the reputation part. So in this view, they always assume that the consumers hold a constant ambiguous belief about the quality, but do not have ability to update it. But in reality, the reputation is there, so the consumers are always updating their beliefs about the quality using the track records of the firms, including the lawsuits, historical lawsuits, scandals, or any kind of penalties from the government during the law enforcement process. So these things are there, and the reputation really plays a very similar. It can mitigate the quality problem and do some positive effects. So the key puzzle here is that if we take the reputation into consideration, how do we set the entry regulation level? and how does the entry regulation level may interact with the market-based reputation mechanism to affect the service quality and welfare. So let me go into the details. First, I want to show you an example to show the consequences of the low quality provisioning. And I will take the example from my paper's context, it's environmental impact assessment. So this industry works like this. So once you want to build a project, either a hospital or any kind of factory facilities in the factory, you need to first assess its impact on the surrounding environments. And this assessment, well, not done by yourself. You need to, by regulation, you need to seek a third-party professional agency to do this. These agencies are called AR agencies, and this procedure is required by more than 90% of the UN member states. So it's a general procedure. And in China, recently, there's a big issue occurred in this industry. That is a Shanghai developer just pledged over $1 billion lawsuit over the land, both the land sellers and the one ER agency. So the reason is that both of these two entities fail to disclose that the land sold to this developer is highly polluted. And as a result, the developer have already started a residential building program, and they suffer a lot of lose from it. You can think about how much they will lose if the low quality service is provided to these clients in such an industry. So to encounter this problem, one way is market-based, it's reputation. So here I will take the typical example of the Arthur Andersen. So Arthur Andersen is the former fifth largest auditing firm in the US, and they claimed that they are very good at talking with their customers, but of course, the later story told us that they are very bad in talking with their investors. The annual scandal occurred, and this Arthur Andersen is found to help hide over 10 billion debts from the financial statement of the annual company. And as a result, its reputation is totally ruined, and the clients do not want to seek service from this firm, and this Arthur Andersen firm become quickly bankrupted. And on the other side, so once the reputation scandal occurred, you will always find that the regulation changes. And in the case of the annual scandal, after the annual scandal occurred, in the US, the auditing industry is experienced a large reform. So they strengthened the administrative entry barrier. Once you want to become an auditing firm, you need first get the registration in the PCAOB and get the permissions from the state level government. And then all of your auditors hired need to get a CPA license. But in China, you will find that in the ER industry, they go to a totally opposite road. So they abandon the licensing system. They reduce the minimum requirement on the certified staffs. So it's an entry deregulation. And if you look at the history of the service industries, these things are always happen. So start from the no regulation and followed by some regulation, then deregulation, and then re-regulation. So given these regulatory flip-flops, we want to really understand is that what is the optimal regulation level or the intensity and timing of the entry regulation, given that the reputation really matters. Okay, so what I do in this paper is first, I provided some empirical facts. I investigate the environmental impact assessment industry in China, and also two empirical questions. So the first, how does the entry deregulation reform I mentioned before may affect the market outcomes, including the number of the new entrants or the service quality and etc. The second question is, how do the consumers respond to the reputation changes? So here I will use one negative reputation shock as an example to show it. And combining these two separate effects of the reputation and regulation, so I will go to the illustrative model and incorporate all things we care about, including the market power, the quality uncertainty, and the reputation formation to answer the third question. So how do reputation dynamics may change the effect of entry regulation and quality? And lastly, I will go to the empirical model. So I will develop a dynamic oligopoly model, and the equilibrium concept that I use here is a moment-based Markov equilibrium. I will estimate the model using the ER industry data, and then conduct some policy simulations. And I will answer the last question. So what determines the optimal intensity and timing of entry regulation when the rotation really matters? So let me go a little bit details into the context. As we know, the ER industry, the ER agencies provide service to the customers once they want to build a project. So they will then collect the construction plan, collect the surrounding environmental reads, and then put all these things into simulation software and generate some predictions on the output. So once the project is established and start to operate, what the environmental outcomes will be, and what is the impact on the pollution, like biodiversity, and the people's residents' health. So these things are done by the ER agency. You may concern, why do these customers have the incentive to get some high quality service from the ER industry? So the major reason is the penalty. So the authorities will penalize these customers who has overpolluted projects. So as a result, they really need to seek this service. And the high quality is also important because it ensures that clients complying with the environmental regulation, and also informs the regulators and the citizens the environmental impacts. And but the quality is very